6 2/5 is equal to 6 times 5 over 5 plus 2 over 5. 5 over 5 is 1. 6 times 5 over 5 is 30 over 5. 30 over 5 plus 2 over 5 is 32 over 5. So the mixed number 6 2/5 is 32/5. The shortcut for doing this is to multiply 5 times 6 and get 30, and add 30 and 2 to get 32 over 5. Going the other direction from an improper fraction, 47 over 8. 47 over 8 is equal to 40 over 8. That's as many. This is the largest number that 8 divides evenly into that's smaller than 47. Plus 7 over 8. And so 40 divided by 8 is 5. And so this converts to 5 7/8. Number 22 asks whether 110 is composite. Well, we know immediately it is not, because 110 is 11 times 10. And since it's expressible as a factor of two whole numbers, neither one of which is 1 or the original number, it's composite. 10 can be factored down into 2 times 5, and so the full factorization is 11 times 2 times 5. Number 23. 23 is not divisible by either 2 or 3 or 5. These are the beginning of the prime number sequence, and therefore it's prime. Note here that you don't need to check any numbers higher than 5. The next prime number would be 7, because as soon as the prime that you're checking has a square that is at least as big as the number, if you haven't found a prime that divides the number at that point, the number is prime. Since 5 squared is bigger than 23, 23 is prime. Number 30, 8 over 14 in lowest terms. We can factor 8 as 2 times 4, and we can factor 14 as 2 times 7. Since these are multiplicative factors, 2 in the numerator and in the denominator, they can be canceled out, and the remaining factor is 4 for the numerator and 7 for the denominator. No more common factors, and that therefore is in lowest terms. Number 50, we're asked to multiply two fractions together. 7/4 times 6/11. We can factor the 4 in the denominator here as 2 times 2. The 6 in the numerator in the second fraction is 2 times 3. Again, all the factors in the numerator, 7 times 2 times 3, are multiplicative, and the denominator, 2 times 2 times 11, also are multiplicative, and the multiplicative factors that occur in the numerator and the denominator can be crossed out, which means this 2 and this 2 can be crossed out, which leaves 7 times 3, 21 in the numerator, and 2 times 11, 22 in the denominator. Number 58, 3 divided by 12 over 7. Dividing by 12 over 7 is the same as multiplying by the reciprocal, which means 12 over 7 flipped upside down. And so looking at this, we can factor the 12 in the numerator is 3 times 4, cancel out the 3's, and conclude that the reduced answer is 7/4. Note also in this example that 3 divided by 12 over 7 can be written this way. It can also be written as a fraction. So in other words, the divide symbol here is the same as a fraction symbol. They mean the same thing. Question 92 asks whether x equals 18 is a solution of 5/3 x is equal to 30. And in order to check that, we will substitute x equals 18 in for x. 5/3 times 18 yields if 18 is factored as 3 times 6, that the 3 in the numerator and the denominator cancel out, which simply leaves a 5 times 6, and therefore 30 equals 30, a true statement, which means that x equals 18 is a solution of the original equation. In 98, number 98, we're asked if z equals 20 is a solution of 12 minus 1/4 z equals 1/2 z. And to ascertain whether or not that is so, we substitute 20 in for z. 1/4, 12 minus 1/4 of 20 is equal to 1/2 of 20. 12 minus 20 over 4 equals 20 over 2. 20 over 4 is essentially 20 divided by 4, which is 5. Here you see this fraction symbol behaving the same as a divide. Same comment I made up in this problem up here. And on the right side of the equal sign, 20 divided by 2 is 10. So 12 minus 5 is 7. 7 equals 10. That's clearly not true. Therefore, z equals 20 is not a solution.